As was said in an earlier video, recall that two inequalities joined by the words and or are called compound inequalities. In this video, we're going to be focusing on those joined by the word or. Remember from earlier that the solution set of a compound inequality joined by the word or is the union of both of the individual solution sets. In other words, this will include all values that are a solution to either one of the solutions. So remember in our video, our last compound inequality video about and, we talked about and actually imposing more restrictions and therefore making the solution set sort of smaller. Now the word or is saying we'll take either one. So if you're a solution to either A or B, then you would be in the intersection of A union B, right? So we just take both. So it's being like less picky, you're a little bit more laid back, like sure, no problem. So let's look at that actress Diva here, the problem that we're talking about. So say now she says in her dressing room that she's happy with anything green or candy. So we've got this or here. So now she's being more laid back, right? She'll take green things, she'll take candy, either or. Okay, so let's look at which of these objects would be things that would be in the solution, green, union, candy. So broccoli is green. So I don't even have to think about whether it's candy or not. It's in the solution set for the union, right? It's as long as it's a member of one of these two solution sets, then it's definitely going to be a member of the union. Okay, so and this green apple is green. So again, don't even think about whether it's candy or not. It goes in. This flower is not green and it's not candy. So this is not going to go in the union. So that guy doesn't go into her dressing room. The green jelly beans are, of course, we already saw that that was in the intersection, certainly in the union, because it's both green and a candy. The yellow M&M is also going to belong in the union because it's a candy. The purple lollipop is going to go in here because it's a candy. The red M&M is going to go in because it's a candy. The green starburst are going to go in because it's both the green and it's also candy, but we'd only need it to be in one of them. The carrots are orange and they're not candy, so unless we're going to count this green part, I should have picked a picture that was purely orange. So I'm going to say that these carrots are orange and they're not going to belong. The flowers are green, and so even though they're not candy, they're going to belong. So unlike the and compound inequalities, the or compound inequalities are sort of, as we were saying earlier, like it's less picky. We're going to have bigger solution sets because we're allowing anything that's a member of either one of these solution sets to belong. So it's just taking everything, the union. Let's look at that math example that we saw in the and video. Okay, so we had these two sets. A was the numbers 1 through 6, and B was the set of all odd numbers. And we looked at the Venn diagram to find where they intersected. So what is it going to look like to be a solution to A union B? So what does that mean? That means we'll take anything that's in A, but we'll also take anything that's in B. So we're going to be taking all the odd numbers, all infinitely many odd numbers that we can't possibly list. We just write it as X, such that X is an odd number. But we also want to include some numbers that are in A. Now, we've already included the 1, 3, and the 5 because we're already taking everything that's an odd number. And we don't want to double count things in the solution set. So we're not going to rewrite 1, 3, and 5. That is already going to be accounted for when we talk about taking all odd numbers. But we're going to also need to add 2, 4, and 6. So the solution to A union B is going to be all X, all values, all numbers, such that X is an odd number, but also we're going to include the numbers 2, 4, and 6. Okay, so this would be everything that's in A or B. Okay, let's also revisit this inequality problem we saw in the last video. We had A was the set of numbers that are greater than 4, B was the set of numbers less than or equal to 20. So we looked at the graphs of these, and remember that the intersection was just the overlap. So what is the union A or B, A union B, going to look like? Well, we want to take anything that's an element of A or B. So if I look at B, B takes everything going all the way down from negative infinity all the way up to 20. So I certainly need to include those values, but I don't have to stop at 20 because where 20 stops, A continues on and just moves forward. So you want to take anything that's an element of either A or B. So we see that we're going to actually be shading the entire number line. Okay. Now, just like in the last example, we don't want to double count. So I don't want to count the portion from 4 to 20 twice. So I'm just really looking at what are all the values that get hit and just list them once. So A union B is actually going to just be everything from negative infinity up to positive infinity. Okay, but it is just going to be just looking at the overlap. Sorry, not the overlap. Anything that's in both. We just don't want to double count. Okay, so let me look at one more example here. So say we have an example where A is the elements 6, 8, 10, and 12, and B are the numbers 9, 10, 11, and 12. So another example where we're not double counting. We want to take anything that's in A or B, but we don't want to double count. So I'm going to take the numbers 6, 8, 10, and 12 because that's everything in A, but I'm not going to rewrite the 10 or the 12 to double count them. I just want to add in the other values that I haven't hit yet. So I also would want to write in 9 and 11. Now it's a little silly the way I've written this. Usually you would write it in order. So I would write 6, 8, 9, 10, 11, 12. But I was just trying to demonstrate that we don't sort of double count the values in the solution. So we're just taking the union. We're taking anything that's an element of A or B, but don't double count. Don't rewrite the same values twice.